Hi, I'm Kian, and today I want to show you an example of a vector word problem. So how do we solve it? So we have vector m, and vector m as a magnitude. This two absolute value signs show the magnitude. A vector m has a magnitude of 36 and has a direction of 240 degrees. And we have another vector, vector b, which has a magnitude of 18 and a direction of 120 degree. We want to find, our goal is to find the coordinates, the xy coordinate of both vectors, and find the sum of those vectors, find the addition of those vectors, and find the direction and the magnitude of the sum of these two vectors. So how do we find it? So first of all, when we have we're working with magnitude with vector m. So I write here vector m. So when we have the direction and the magnitude, the coordinates are very easy to find. Why? Because for a, like in this case, vector m, its x coordinates is the magnitude multiplied by the cosine of the direction. So this will be 36 times the cosine of 240 degrees, and the y coordinate would be 36, which is the magnitude, multiplied by sine of a direction. 36 multiplied by sine of 240 degrees. And the y coordinate is 36 times the, here's cosine, let me write it. Let me write cosine of 240 degrees, and the y coordinate is 36 times sine of 240 degrees. So how do we find it? So we need a little trig value. So we should know the unit circle. For finding the cosine at 240 degrees, first of all, we should know that 240 cosine at 240 degrees is when like 160 degrees is added to 180 degrees. If you know that the angle of 180 on the unit circle is just on the x-axis. So when we add 60 degrees, that means that 240 degrees, its cosine and sine, are located in the third quadrant, which are both negative, which means we should find a value that is negative. And what value? Because we added 60 to 180, we should find the cosine and sine of 60 degrees and multiply them by -1. So cosine of 60 degrees is a very known value, is negative 1 over 2. It's 1 over 2, and then multiplied by negative becomes -1 over 2 because we're in quadrant 3. So 36 times -1 over 2 is negative 80, 18. So vector m, its first x coordinate is -18. And its y coordinates, again, sine at 240 degrees, again, because we're in the third quadrant, we should find sine of 60 degrees, which is root 3 over 2 multiplied by negative. We get negative root 3 over 2, and the 2's cancel, so we get negative 18 root 3, because the 2 and 36 cancels, and we get negative 18 root 3. So now we are finished with finding the coordinates of vector m. Now we're going to find the coordinates of vector b. I'm gonna go to the next page. So for finding the coordinates of vector b, it is very easy because we have vector b. Again, we use the formula that we should multiply the magnitude by the cosine of the direction for the first part, for the x coordinate, and multiplying magnitude by the sine of the direction. So the magnitude here is 18, so we should multiply 18 by the cosine of the direction, which is 120 degrees. 120 degrees. And then for a y coordinate, we should multiply 18 by sine of, multiplied by sine of 120 degrees. So now, for finding the cosine of 120 degrees, again, look at the unit circle. We know that 180 is on the x-axis, and 120 degrees is 16 minus 180 minus 60. So that means we should go to the second quadrant. So angle of cosine of 120 degrees and sine of 120 degrees is located in the second quadrant, which means in the second quadrant, the x-coordinate is negative and y-coordinate is positive, which means the cosine of 120 degrees is negative and the sine of 120 degrees is positive. So cosine of 120 degrees, again, we should find the cosine of 180 minus 120 is 60. So we should find the cosine of 60 degrees, multiply them by and negative, and then multiply by 18. Cosine of 60 degrees is 1 half, multiplied by 18 is 9, and by negative 1 is just negative 9. So the x-coordinate is negative 9. Sine is the same, but we don't want to multiply by negative because sine is positive. So sine of 120 is just root 3 over 2, and the 2 and 18 simplify. We get 9 square root of 3. Now we have the coordinates for both vector m and vector b. And now what we want to do is that we want to first add them and then find the magnitude of and direction of the resultant. So when we add these, so when we add negative 9 comma 9 root 3, when we add that to what was our vector m, it was negative 18 comma negative 18 root 3 plus negative 18 comma negative 18 root 3. So we should add the x coordinates and then add the y coordinates to get the resultants. So when we add negative 2 and negative 18, we get negative 27. And when we add 9 root 3 with negative 18 root 3, because the roots are the same, we just add 9 and negative 18, we get negative 9 root 3. We get comma, negative 9 root 3. Now this is the negative 27 comma negative 9 root 3 is a resultant after adding the two vectors of b and m. Now I want to find the magnitude. So the magnitude, so let me write it here. The magnitude of resultant vector a b plus vector m. So first of all, we should use the Pythagorean theorem. So negative 27 squared is 729. And then when we square negative 9 root 3 and then add them and then take the square roots, what we get is the simplest form of 18 root 3. So using the Pythagorean theorem, we found the magnitude of the resultant of vectors, which was 18 root 3. Now we have one more thing to do because we want to find a direction of this vector, vector b plus vector m, which will result in another vector. For finding a direction, which we should evaluate the inverse tangent of the y coordinate of this vector over the x coordinates. So how do we find it? I will explain to you how. Inverse tangent. So what I mean that because we're left with a vector b plus vector m, when we add two vectors, the resultant is another vector. In this case, our vector is at x coordinate -27, y coordinate -9 √3. So for finding the inverse tangent, we should divide the y coordinate of the vector over x coordinate. When dividing, -9 simplifies as -27. -9 it becomes 1, and then -27 becomes 3. So we're left with the inverse tangent of √3/3. Now, this part is very important because you should pay attention in what quadrant is your vector located. Because for the inverse tangent of √3/3, we have lots of different angles that has a tangent of √3/3. So how should we find it? So first of all, we should take a look out at our vector and see in which quadrant is located. When we look at it, we see that both coordinates are negative, which means this vector is located in the third quadrant. In the third quadrant. So, tangent of √3/3, because we are tangent is equal to inverse tangent. Tangent is equal to sine over cosine. So we should find an angle that has an inverse tangent of √3/3. How? So, for example, let's choose an angle, like, because we want to find the inverse tangent of √3/3. First of all, we should take a look at because what are the three simplest angles that for trigonometry is 30 degrees, 60 degrees, and 45 degrees. We know that it can't be 45 degrees because tangent of 45 degrees is just 1, but we can choose between 30 and 60 degrees because we know that tangent is sine over cosine. For example, if you use 30 degrees, sine of 30 degrees over cosine of 30, sine of 30 degrees is 1/2 over cosine of 30 degrees, which is √3/2. And if you simplify, you get 1/√3. And if you rationalize the denominator, 1/√3 is the same as √3/3. So our angle should be a multiple of 30 degrees. So what it means that because we are in the third quadrant, we should add 30 degrees to the 180. Why? Because 180 is located on the x-axis. And if we want to find an angle that has a tangent of √3/3, we should add 30 degrees to be located in the third quadrant. When adding 30 plus 180 degrees, we get 210 degrees as our direction. So 210 degrees as our direction. Yes, and direction. And we are done. Thanks for watching. Please subscribe to my channel and watch previous videos. Goodbye.